Okay, hey guys. This is Trig section 5.4. This is like the first half of it. I tried to record during class, but it for some reason shut off after like the first example. So I'm re-recording this. I'm doing this at home, so I might move a little bit faster. But common and natural logs, this is kind of like our introduction into logarithms, I guess, for this chapter. And so from here on out, we'll be discussing logs and exponential functions a lot further. So there's two types of logs that they introduced to us in this section, and one of them is a common log. And a common log is just log, and you have an log button on your calculator. So kind of like these logs down here, log of 1,000, log 1, whatever. You can have logs of different bases, and normally they are represented with like a subscript. So like this would be log base 2. If it does not have a number, you assume that it has a base of 10. Okay, so if it just has log like these do down here, these are all in log base 10. Okay, that's just kind of like the understood number. Okay, so log base 10 is a common log. That's what a common log is log of base of 10. And what we will get into is switching back and forth between a log and an exponential function. Okay, an exponential function, like the inverse of log base 10, is 10 to the x power. So those are inverses of one another. They undo one another. So 10 to some power is the inverse of log base 10. Like log base 2, his inverse would be 2 to some power. Okay, and we've been dealing with exponential functions already, so this should kind of seem familiar. But now we're having to deal with logs. Okay, natural log is the other one. And natural log, there's a button on your calculator that is ln. And that is natural log. I don't know why they don't say NL, but ln is a natural log. Oh, excuse me. And ln is a log, but it is log with a base of e. So a lot of times going through here, what we will do is rather than putting ln, we'll cross him out and we will represent him as log base e, okay? Because that's what he's equivalent to. He has a log of base e. Now, if he is log base e, then his exponential function is e to the power of x. And we've kind of seen that in the PERT equation that we've had before. Those guys are inverses also, okay? So that is a natural log versus a common log. Okay, down here, they kind of give us the example of how to go back and forth between a log and an exponential function. So here, if we look at this log, the base of that log is 10 because there's no number there. And this says log base 10 of v equals u. I don't know if you can see that very well. It's fuzzy. Okay, if we try to make that into an exponential function, these are the exponents, these are the logs over here. If we try to make it into an exponential function, the base of the log was 10. It stays the base of the exponential function. That stays in the same spot, but these two values kind of switch places with each other. So now it is 10 to the power of u is equal to v, and that's kind of how that works out. So log exponential function. Let's go down to like this example down here, this second line in this box. If we have log of 29, again, that's log base 10 of 29 equals 1.4624. The base stays the same number, so we go over here to its exponential function. 10 to the 1.4624 equals 29. These two switched places with each other. Same thing here. This is a log base 10. This says 10 to the 2.5775 equals 378, like what it says over here. So that's kind of how it works back and forth between logs and exponential functions. The first number stays in the same spot. Second two numbers switch places with each other. Okay, so down here they're wanting us to, on A, B, C, D, these are really quick and fast. Without using a calculator, they want us to find each value. Okay, so one thing I'm going to do on part A is, we know that that's a base of 10, so I'm going to go ahead and put 10 in there, but we're trying to evaluate that thing, okay? So I'm basically trying to figure out what he's equal to, and for right now, I'm going to put equals x, and then basically find what x is, because we're trying to find the value of it. So put what x is. Now, after I put equals x, I'm going to go down here, and I'm going to change him from a log, because that's what he is right now, to an exponential function, okay? So I switch him around, and this just says 10 to the x power equals 1,000, okay? And then you just ask yourself how many times you have to take 10 times itself to get 1,000. X is equal to 3. 10 to the third is the same thing as 1,000. And then it's pretty easy to solve for. Without using a calculator, you can look at that and say, oh, it has 3 zeros, x is 3, okay? If we go to B, over to B, Again, this is a base of 10. I'm going to say equals x. And this, if I make it an exponential function, says 10 to the x power equals 1. And so we're like, okay, how many times do I have to take 10 times itself to get the number 1? Well, we know that anything to the 0 power is 1. So 10 to the 0 power is 1, and that's what x has to be in this case, okay? So we go to c. C, again, this is a base of 10 equals x. If I flip this around, this says 10 to the x equals the square root of 10, okay? And so this is kind of asking, like, the square root of 10, this guy right here, what is that as an exponent? What's a square root look like as an exponent? And we know that that's to the 1/2 power, right? 10 to the 1/2 power is the same thing as a square root. So x in this case is 1/2, and that's going to be the value of log square root of 10, okay? Over here, D, this says log base 10 of -3, and we're going to say equals x. So we say 10 to what power will give me -3, okay? So this one we kind of have to think about, because we did like 10 to the 3rd power is 1,000, right? And we've done 10 to the 1/2 power is a square root, right? The square root of 10 or whatever, which is 3 point something, right? Even if we do, like, let's say 10 to the -1st power, that is 1/10, right? That's what negative powers do, is they flip them to the bottom. So in all of these examples, I can make the exponent be a whole number. I can make the exponent be a fraction. I can make the exponent be a negative number. But the problem is, none of these numbers that I get as an output will ever be a negative number. So this one is no solutions. I can have exponents, any type of exponent I want to, and I will never get a negative number. So -3 is not going to be able to happen, okay? All right, if we go down here, solve each equation by using an equivalent statement. That's, again, this is a log function, and we want to make it into an exponential function, okay? So this is a base of 10. And so we're just doing 10 to the 2nd power equals x, and then we just evaluate, right? 10 squared, or 10 to the 2nd power, is 100. So 100 equals x, and that is his value, okay? Letter B, this one is an exponential function, so we have to flip it around to make it a log function. They want us to write the equivalent statement, so basically saying flip it around to the other form, okay? So he's an exponential function. We want to make him a log. So this is saying log with base of 10 of 29 is equal to x. Okay, log base 10 of 29 equals x. And then, so really your calculator will not have that 10 there. It'll just be log of 29 is what you will type in. So find the log button. It's close to like the 7 on your calculator, like the button 7. It's just to the left of that. I'm going to be using my phone calculator. So let's see if this works. I'm going to do 29 log. You'll do log 29 log. And it is, we always round to 4 decimal places. So 1.4624 is what that will be. Okay. So again, you're just switching it out to the other form and then just evaluating using your calculator. Okay. Or doing it in your head like this one we could. Okay. All right. Now, natural log, a natural log we said was ln, and I'm going to write off to the side over here that ln is equivalent to log with base of e. So every time we're doing an ln, we're going to evaluate as log base e. But it's the same thing when we're switching from a log to an exponential function. ln of 14 equals 2.6391, okay? Rather than switching it, or before I switch it, I'm going to make that and write it out to say log base e. And then I can switch it, and I know that the base, this number has to stay in the same spot, and these two numbers switch places. So this says e to the 2.6391 equals 14. E to the 2.6391 equals 14. Okay, ln again is log base e. What?
Mommy, I want to turn this for you.
Okay. And this says e to the this power equals this guy. Okay, e to the that power equals that guy. Okay. All right, and then we're going to go down here, and these first couple problems in example 3, they're just having you practice typing this into your calculator, okay? So this says ln of 0.15. Your ln button should be really close to your log button on your calculator. So you just hit literally ln of 0.15, and we're going to, let me see, 0.15, ln of that. And I get negative 1.8971, something like that is what he shall be. Okay. All right. ln of 186. Okay, same thing. You just type in ln 186 and you should get something like 5.2257. We don't have to rewrite him in the other form because we're not really solving for like an x or anything in that equation. You just type it in, okay? This one is ln of -5. Now, we set up above here that like log -3, you can't evaluate a log of a negative number. Well, ln is just the same thing as a log, right? It's log base e. So still, if you try to type it into your calculator, let's see what mine says. I'm going to do, if I do ln of -5, it says error, okay? Which means that there is no solution because you cannot evaluate logs of negative numbers. Now, it's a little bit confusing because down here in part A, we did get a negative number as an answer, but you cannot evaluate log of a negative number, okay? So you can get a negative as an answer, but you cannot type a negative into your calculator. Hey, all right. Okay, all right, example 4, I think maybe this is the last one that we did. So example 4, solve each equation by using an equivalent statement, okay? So that just means switch it to the other form. So part A is in log form right now. They want us to make it an exponential function, okay? So before I do that, before I switch it to an exponential function, I'm going to rewrite this ln as log base e. Before I even switch it, I'm just going to rename it, okay? And then I switch it so the base stays the same. This would be e to the 4th power equals x. And then all you're going to do is just type that into your calculator, okay? So I'm going to go e to the 4th power. Now e, to get the e button, this is on your calculator, it will be shift ln, okay? So you'll have to shift ln. That's how you'll get to that e button. And I guess we typed in e when we did the PERT stuff in the last section. So I'm going to go e to the 4th power, and you get something like 54.5982, something like that. We'll go 4 decimal places, okay? Next one, part B. This is in an exponential form, so they want us to do the other form. They want us to make it into a log form, okay? And so we write it as a log, and log with base of e. Those two stay in this, or the first number stays in the same spot. Then 5 goes in this spot equals x, okay? So we have log base e of 5, and I'm going to type that into my calculator, but before I do that, I'm going to switch this. Log e is the same thing as ln, and all I have to do is type in ln of 5, okay? So I'm going to go ln of 5, and it tells me that that is 1.6094, okay? So all we're doing in this first section, that should get you through the front side of the homework. Homework looks like this, so 5-4. It should get you all the way through here. You might have a little bit of trouble with number 14, but after tomorrow's lesson, we'll know how to do that one also. So just save the back side, but 1 through 13 really, and that should get you through those. These first two, if they don't have an equal sign, just set them equal to x, and that's going to help you switch them around, okay? But all you're doing in each one of these is if it's a log, you switch it to an exponential function. If it's an exponential, you switch it to a log function. And then you evaluate on the ones that they want you to evaluate, okay? So that should get you through. Tomorrow I'll send you the video of the second half, okay?